Let's take a look at this triangle right here. We have an opposite side and we have a hypotenuse. These are the two sides we're interested in. Now, this graph paper, on this graph paper, 4 squares is 1 inch. Actual size. So, I want to show that I have 1 inch shown here. I wrote that, and it's 4 squares up. Now, if you could take this hypotenuse and you could swing it up to 90 degrees, you'd see that hypotenuse measures 1 inch. Now, notice also that right here where I have 0.5 inch, you have 2 squares, so that's 0.5 inches literally. And follow that across, and you see that the opposite side is 0.5 inch. We have an angle right here, 30 degrees. So let's take a look at the sine of 30 degrees. We get 0.5. Now in this case, we can take that to mean 0.5 inches. Okay, so notice that the hypotenuse measures 1 inch and the opposite side measures 0.5 inch. And that means that the opposite side, the length of the opposite side is 0.5, the length of the hypotenuse. So, knowing this, we could also say that the hypotenuse is 2 times the length of the opposite side. Okay, now let's look down here. Where down here, I have the opposite side length. You see its height right there, followed across, and you can see in this case that the opposite side is 1 inch. And you can see that here's the hypotenuse. It's the same. This is the same triangle as up above. 30-degree angle. Now, if you look at this hypotenuse and swing it up to 90 degrees, you see it measures 2 inches. All right. So when we say that, knowing that the opposite side is 0.5 the length of the hypotenuse, that also means that the hypotenuse is twice the length of the opposite side. Let's just prove that on a calculator. Okay, so let's take the length of the hypotenuse is 1 inch, and let's divide that by 0.5, and we get 2. Okay, now there's another way to do that. Since that 0.5 right there, we got that from the sine of 30 degrees. So let's do it another way. The length of the hypotenuse, 1 inch, divided by the sine of 30 degrees, and we get 2. Okay, now, just like above, we can take that to mean 2 inches. And what that is right here, what I just did right there, 1 divided by sine of 30 degrees is the cosecant of 30 degrees. And it looks like that because instead of actually being the cosecant of 30 degrees, it's 1 divided by sine of 30 degrees, because there is no cosecant button on a calculator. I've never seen any calculator with that button, and there is no secant button, and there is no cotangent button. And it makes sense because this cosecant button is really just if you found the sine of 30 degrees, you automatically know from what that information. You already know from that information that the hypotenuse, in this case, is twice the length of the opposite side. You already know that. You don't need the cosecant button. So that's why you'll see a lot of people say the cosecant of 30 degrees, and they'll do it this way, 1 divided by sine. So I just wanted to clear that up, what that, why you see people doing that, 1 divided by sine for cosecant. Okay, that's why they do that. Now, notice that, let's make a statement about both of these. Notice that up here, where the opposite side length is 0.5 inches, the opposite side is 0.5 the length of the hypotenuse. And notice that down here, the opposite side is 1 inch, and the hypotenuse is 2 inches. And the opposite side length is also 0.5 the length of the hypotenuse in both cases. Also, in both of these cases, the hypotenuse is 2 times the length of the opposite side. Well, in this example, where the hypotenuse is 1 inch and the opposite side is 0.5 inches, the hypotenuse is 2 times the length of the opposite. And that's also true down here. When the hypotenuse is 2 inches and the opposite side length is 1 inch, the hypotenuse is 2 times the length of the opposite side. Now, let me just throw one thing in here. I'm going to show you a case where I knew in this case here, this is a truss that I have a video of how to make on my channel. Okay, so this is where a cutter, that's a cutter, and it's going to travel and make that cut like that. And then here's the cutter on this side, and that's its travel. Okay, so this material here, this is the parent material, that will be left behind. We're not cutting that out. So it has a width, and I wanted it to be equal to this. Also is parent material that we're going to leave behind. So we have again, same thing. We have the cutter. That's a picture of the cutter, and it will travel down to there, and it'll make that cut. And then on the other side, there it is again. That's the cutter's travel, and this parent material left behind has a width, and I wanted this to be equal. But you see, the graph paper don't really help you do that. But right here, I can see it's 3 squares times the value I gave each square. So what we do is we have this number right here. See the purple is from the center of the cutter to the center of the cutter on each side of that material we're leaving behind. So that's basically the width of the material we're leaving behind plus the radius of the cutter plus the radius of the cutter again. So we have a number. We have a length. And that length we apply right here. And I don't have a picture of a cutter here, but there would be if I put it there. So if I had a picture of a cutter right here, it would look just like that. So since we have, this is a length that we have. So let's put it here. And there's the length there, 0.2306 inches. And what we need to know is, what is this distance here, the orange? So in this case, we know the opposite side length, and we need to find, this is a hypotenuse now. If you hold it on the right angle, it would look like, that's the hypotenuse. Here's your, okay, let me say this. This is your 90 degree right here. That's your 90 degree corner. So that makes this the hypotenuse. Now, in this case, because we know the opposite side length, we want to use the cosecant of, in this case, the cosecant of 36.86 degrees. And then we multiply that by 0.230, which is, that's the opposite side length. And then we get 0.384 inches, and that is this hypotenuse length. And that's where, when I write the plans for making that truss, that's the number that I'm going to look for. That's the number I'm going to use. That's the distance I need the cutter to, from where the cutter stops, where it makes this cut, Don't go any further than that. And then I know I have to jump over this amount of material. I have to pull the cutter out, and I have to go that far. That's that distance right there before I can. So I jump over the material, pull up, go over the material, and plunge back in here. That's that number. And I got that from the cosecant of 36.86 degrees times the opposite side length. Anyway, that last part, that might be a little bit confusing. The point was to just to explain sine of 30 degrees without saying the word ratio. I'm not sure I should have added that last part there, but